in the 2010s, it was a really glorious period of AI research. Around 2019, 2020, things started changing, as we know. The entire industry got more closed off. The researcher in me was deeply dissatisfied. Even though capabilities were going through the roof, openness and transparency were going down to the floor.
Do you also think part of this conversation is also about capture, where companies that have billions of dollars of investment now in closed models have an incentive to sort of make sure that there aren't open source models that are as competitive?
If we can, as a community, get on the same page with this idea that we want something like Linux for foundation models. Independent, it is fully transparent, and it's something that everyone can build on, then I think we maybe have a hope where people can contribute. Because I really believe that the future of AI should be much more decentralized and much more open. That led to the founding of Together with this mission of how can we build a platform that enabled many more people to participate and develop based on the open model ecosystem.
Welcome to another episode of Together Talks, a series of conversations with researchers and industry leaders about generative AI, brought to you by Together AI. I'm Vipul Prakash, co-founder and CEO of Together AI. And today we have a very special guest, Dr. Percy Liang. Percy is a renowned professor at Stanford, the director of Center for Research on Foundation Models, and one of the pioneers in the field of NLP. He has received a multitude of awards, including the Presidential Early Career Award for Scientists and Engineers, the HKI Computers and Thought Award, an NSF Career Award, and many more. Last but not least, he's also my co-founder at Together AI. Percy, it's an honor to have you here, and I am very excited for this conversation.
Thank you, Vipul. It's a pleasure to be here.
So I believe, you have this really unique and comprehensive perspective on the evolution of this field. You were training models back in 2005. Can you talk to us more about that?
Yeah, so in other words, I'm getting a little bit old. But it's been a while. And back in 2005, I was a master's student at MIT. And at that point, so this was before deep learning. This was when people were sure neural networks weren't going to work.
Right.
And at that time, machine learning was already dominant in NLP for over a decade. But it was all supervised learning. And supervised learning meant that for every task, you had to get a lot of annotated data. And this was even before Amazon Mechanical Turk. So you couldn't crowdsource data easily. So you had to hire people, often linguists, to provide this form of data. It was very slow and painstaking. So with my master's advisor, Mike Collins, we set out on a charge to understand, well, there's a lot of raw data. There's unlabeled data. How can we leverage that? And so the natural thing is to train a language model.
Right.
What else are you going to do with a bunch of text? And of course, at that time, there's no transformers, no neural nets. So the type of language model we trained was a hidden Markov model. And we trained it, I believe it was around 40 million words. So maybe that's like 100 million tokens, maybe 2 or 3 orders of magnitude, maybe 4 orders of magnitude less than what we have today.
Right.
But the idea was the same. The idea was that you would train this model to predict the next word or maximize the probability of the next word. And once you do this using an algorithm called Brown clustering. Actually, Brown clustering was invented by IBM researcher in the early 90s. So this was a while ago.
Fascinating.
Yeah, the IBM researchers is a tangent, but they did a lot of good work, which was kind of ahead of its time before the team eventually disappeared into finance. But it was with a Brown clustering algorithm. So we trained this hidden Markov model. And what was really interesting is that it was that if you look at the internal states of the hidden Markov model, you would get these word clusters. So somehow automatically it would know that here's all the North American cities, or here's all the days of the week, and so on. So it was just kind of this emergent phenomenon. It would discover structure just
sort of like
objects.
What happens with embeddings now.
It was like kind of the precursor to embeddings. And that was really fascinating. I was blown away, and that's kind of what made me want to really get into AI and be a researcher. Right. And then on top of that, we threw these features into a classifier, and then it was able to improve the accuracy. So it was kind of a success story of this general recipe of leveraging a huge amount of data, or as much data as we could have the resources to manage at the time, and showing that it could help on a bunch of tasks. So the spirit of that is actually very much what we have today, although the details were obviously very different.
Right, so this was like unsupervised learning and training language model. Did you have a sense then that this is going to become as big as it is today, or maybe what point in time did you start feeling, oh my God, this thing is going to be incredible?
Yeah, I wish I had that sense back in 2005, but it took a long time, and I think it took the field a long time to really grapple with that. And I think OpenAI gets a lot of credit for starting with in 2019 and 2020 with GPT-2 and 3, and really just being focused on scaling. And I think that even though I think the lesson, it's sort of like the bitter lesson, is that a lot of the ideas are already in the air, but you just have to kind of apply enough force to make them survive. Really? But yeah, at that time we were just thinking, I was really already pretty impressed with these word clusters. I mean, couldn't imagine like in-context learning and zero-shot learning and the idea of just instructing a model to do various tasks.
I mean, these things were almost fantasies, even in like sort of 2016, 2015 timeframe. We will have in-context learning and zero-shot, but there really weren't any systems that demonstrated that it could work. And then suddenly we had this sort of, explosion of language models and capabilities.
Yeah, I think it wasn't until I saw GPT-3 come out in May of 2020 when I realized, oh my God, this is going to be,
this is working.
Yeah.
How did your journey lead to starting together? Maybe you can
so I think it has a lot to do with the trajectory of the field. So in the 2010s, it was a really glorious period of AI research where people would do things openly. They would release code and data sets. Many benchmarks like ImageNet and Squad and Glue were available, and researchers, hobbyists, startups, they could just tinker with all of these stuff on top of these toolkits like PyTorch and TensorFlow. So the situation was much better when compared to the 2000s, where people didn't really release that much code. And you had to still implement your own gradients and debug gradients. And so life was pretty good. And then around 2019 and 2020, things started changing, as we know. OpenAI became less open, but not just OpenAI, but the entire industry got more closed off. We're starting with GPT-2, where this release was staged. They didn't release it immediately. There's a lot of controversy about that. GPT-3, it was never released the weights. They still had a paper on that. And then GPT-4, the paper was very honest and explicit, saying we're not talking about any details about the data and the model architecture. So against this backdrop, the researcher in me was deeply dissatisfied. Even though capabilities were going through the roof, openness and transparency were going down to the floor. And so one of the things I remember an early conversation we had in the beginning is, how can we catalyze the open ecosystem?
Right.
Because I really believe that the future of AI should be much more decentralized and much more open. So that led to the founding of Together with this mission of how can we build a platform that enabled many more people to participate and develop based on the open model ecosystem.
Yeah, and I would say that we have really sort of discovered that the open source part of this ecosystem is growing, and it's really being there's a lot of participation in it. How do you feel about it? Like, what is your sense today of, is AI getting more closed? Is AI getting more open? And what do we need to do to make have more open source AI?
Yeah, I think on the whole, the trajectory is positive, and I'm optimistic about that. I mean, compared to 2022, when Together was founded, there was no open models that you could really. I mean, there were some open models, maybe GPT-J, and remember we also fine-tuned the model, and there was Bloom,
right?
And it was really not even competitive with GPT 3.5. And now we have Llama, we have Mixtro, we have many others like DeepRX, and the Chinese models, Qwen is a good model. So I feel like there is a lot more momentum.
Right.
And furthermore, many use cases that companies have or researchers have, you could actually do very well with the existing open models. Now, of course, there's still a gap between GPT-4, Claude 3.5, and the open models. But at least I think there's a lot more energy behind them, as opposed to this sort of almost resigned feeling of like, oh, I will never be able to catch up. So I'm really excited about
where things are going.
Forward.
Yeah, no, absolutely. Yeah. And there is, there's also sort of some different concepts here, like open publishing, open source, open weights. You've talked about these before, and maybe sort of outline for us, like what is this spectrum of openness here, and how does it really impact the future of open source?
Yeah, I think this is a great question, because I think there's a lot of confusion in the air. Like open source AI, I think it becomes a buzzword and it gets tossed around and almost in a kind of marketing sense. But I think there's some deep distinctions here that I think are important to understand. So maybe just to put out three concepts. So transparency, well, actually four: open science, open source, and open weights. So I'll start with open weights. So open weights is the general idea that you have a model whose weights are broadly available, through the public.
Right.
And this includes Llama, includes Mistral models. These are models where you can take the weights, you can host the models locally, or put them on together, or fine-tune them, do whatever you want, look inside. But you don't really know anything more about it, right? It's like shipping a executable. You get an exe file, say, go have fun. You can run it in the
it's
privacy
sort of like the
of home.
shareware equivalent in software, where you have the executable but not the code.
Yeah. So I think you can do a lot, and a lot of the open ecosystem is catalyzed by these open weights. And then you have open source. So of course the word open source goes back to the late 90s from open source software, where the movement was around the idea of, source code being available for inspection and also for derivatives to be made. And if you look at AI, so AI models are obviously a different object, but I think the counterpart would be the training code and the data should be open for a model to be considered open source, because you wouldn't call Windows.exe open source software, right? And so I think it's important to make this distinction, because while we are able to do things with open weight models, I think you can do a lot more with open source models. For example, knowing what's in the training data allows you to reason about, from a researcher's perspective, how impressed should we be at various capabilities? Are we testing on data that's not in the training? And even basic things like that.
Right.
And of course, it has greater auditability. So many companies who don't want to experience copyright risk can kind of audit the training data and see that there's no copyrighted content, for example. Okay, so that's open weights and open source. And then I'll talk about transparency, which I think of as a broad umbrella that encompasses open source and open weights. And the way we think about it is not the whole process of how models get built, from where the data is sourced, things like data labor, where the compute comes from, all the way to how exactly the model was built, to properties of the model, such as whether enough evaluations on capabilities and risks were done, whether the model developers explained what risk mitigations that they used, whether they established proper usage policies, and they documented how this model is going to be used in a while, whether there's feedback mechanisms, and so on. So I think of it as the whole kind of broad ecosystem. And at Stanford, we put out a project called the Foundation Models Transparency Index, where we assess model developers based on how transparent they are across this spectrum. And currently at the top is an open source model. It's Hugging Face, ServiceNow's StarCoder model. But there are many open weight models that are actually not transparent. So they release the weights, but they don't say anything else. So I think this is important to realize that transparency is not the same as open weights.
I assume this ties into one of the ideas right now, or sort of a criticism against open source, is that these models are increasing in capabilities, and having these models open increases the sort of risk that's posed by the models. How do you think about that? Is transparency a way to counter that, or are open source models inherently more risky or less risky?
Yeah. So I think a lot of the criticism around open models is really about open weight models. And the fear is that you have an open weight model, you release it to the internet. Now
Right.
any malicious actor can go fine tune it, turn off safety, which is very easy to do, and use it to generate disinformation or bioweapons or whatever your fear is. And it's true. I mean, it can happen, right? And open weight models have risks. They also have benefits, of course. And closed models have risks, and they also have benefits. So I think part of the problem with this whole discourse around open versus closed is that it's very non-scientific.
Right.
It's very much kind of these sound bites from these opposite sides saying, of course, open weight models are fine. We should, go full steam ahead on innovation. And on the other side, we're going to be doomed if you release open weight models. Right. And I think it's just not a very productive conversation. Instead, I think what we need to do is think about things a bit more, in a principled way. So maybe to provide a little bit of a framework for this. So one concept is the idea of marginal risk, right? So if you have an open weight model, it is true that someone can prompt it, let's say turn off safety, and you prompt it to say, please, generate how do you generate the smallpox? And it can, maybe you'll do it, maybe you won't. But you have to think about, well, you can also find this information online, actually probably on Wikipedia.
Right.
Or you could take a class. I think in general, the knowledge is there.
Yeah.
Right. So you have to compare the risk of using the language model as against without using it. And it might not be zero. Maybe it facilitates the knowledge dissemination, but we have to measure this. And fortunately, I think more and more people are realizing that we need to look at this difference, not just say, oh my gosh, this model generated something that was harmful. We need to shut it down, right? So that's one aspect. The other is to think about the whole ecosystem, right? If you have a malicious actor, and trying to spread this information, it's the language model is only one part of this story. You have to generate it, and then you have to disseminate it. Or if you're generating a bioweapon, you have to generate the recipe, and then you have to manufacture it.
Right.
And often the downstream is actually it's non-trivial. Right. So it's not that
the knowledge exists, but the methods and actually producing something.
This
malicious object is what is hard.
Yeah, so I think to understand the risk, you have to look at the entire pipeline, and and also if you think about regulation, you also have to think about the entire pipeline and where you want to put pressure.
Yeah,
and so I think that needs to be foregrounded as opposed to this disembodied AI just doing harm, because that's never how I think AI work in the real world. It's always with people, and it's contextual.
right. And do you also think part of this conversation is also about capture, where companies that have billions of dollars of investment now in closed models have an incentive to sort of make sure that there aren't open source models that are as competitive?
It certainly seems convenient.
Yeah.
Yeah. I mean, I think there are people at various labs who are deeply concerned about the risk. But on the other hand, it does seem very convenient to take this position, and it aligns with these commercial incentives.
Right.
And one thing I'll add is also that, on the closed model side, the argument has always been we have an API. So you use it and we can monitor it. And if we see anything malicious, we'll just shut you out.
Right.
But this doesn't seem, first of all, it might be at odds with privacy. So how much are you really going to monitor? And also, there's cases where you just can't. So for example, if I'm going to try to send you a phishing email, right? I'm not going to announce to GPT-4, I'm going to send a phishing email to Vipul.
Correct.
What I'm going to do is I'm going to use it to draft a very personalized and compelling email. Maybe it'll be like, top 5 research ideas to improve inference by 10x.
Right.
And with a bunch of links.
Yeah.
Right. And I'll have GPT-4 generate that.
Yeah.
And then I'm going to go in, take my output, and then I'm going to swap out the links with some malicious payload. And I send it. Right. So OpenAI has no idea that I'm doing this.
Yeah. So this is a collaboration between a malicious human and innocent sort of AI system.
Yeah.
And the malicious bits can be, can remain on the human part.
Right. So the question is, how much can monitoring actually do when you can sort of factorize the problem into a sort of a general helpfulness part plus a malicious part?
Right.
And of course, you can't do this all the time, but I think there are many cases that you can do, and which would not be monitorable.
Right.
So I think the answer is to your question is complex, and I think we need to understand the different use cases and think about the whole ecosystem rather than having this very simplistic view of safety.
Yeah, and I would say certainly the amount of research and developer agency that open source models have created.
Yeah.
We have so many participants around the world in this ecosystem, and they are studying aspects of how these models work, how to think about safety, how to think about capabilities and how they can be induced or removed. That just seems like an incredible positive versus 300 people doing this in a
I think that's a great point. So what about the benefits? It's clear that open models have actually catalyzed a whole bunch of safety research, which is badly needed, that wouldn't have otherwise existed. So, one paper from Zico Coulter's lab showed that you can attack an open model because you have the weights. You can do more deeper attacks, and then these attacks actually transfer over to jailbreaking closed models.
Right.
And therefore, it shows that the closed models aren't actually as secure, as we thought, or as I don't know what we thought.
We've been told,
as we've been told. I think that's and this wouldn't have been possible without these open models.
And there's in security by obscurity has always been frowned upon. As something that can't be relied on, and malicious and incentivized actors often use that obscurity to get early access to 0 days and that. So this is the sort of thing that's happening and is likely to happen with closed models that are behind APIs.
I mean, I think if you look at the history of computer security, people kind of tried ad hoc things, like in the in the 70s, and then they realized, well, that doesn't really go go so far. And instead, we should build, the entire internet ecosystem on open standards like, SSL and things like that, where I think everyone can, stare. We can all stare at each other and it's like, okay, this is the code we're running, and anyone can go and find bugs. So, there's this Linus Torvalds has a law that says, with enough eyes, all bugs are shallow.
Right.
Right. And I think, of course, models aren't the same as code, but I think there is something about this which I think still carries over, which is that if you have enough people who are actively trying to, break a system and understand it, you actually get much more secure and safe models and software rather than having it behind a closed.
And I guess some of the sort of attack transfer also illustrates that having open models also makes the closed models stronger in some ways. We can study them better, and you have this better ecosystem overall.
Yeah. And I think right now, I think there's a just general consensus that the existing open models, existing even frontier models like GPT-4, if we were to open weight them, then there nothing bad would happen.
Sure. Yeah.
I think some people believe that in the future, maybe something there was some sort of super intelligent takeover or takeoff or something. But in that case, I would say that, if you are really worried about existential risk, then I don't think we should build closed models either. Right. If you really take that position,
stop doing it. If you
you
really
just
believe in
stop
that.
doing it. So I think either you take a position where, these models are things that we can manage, and then open models I think have just many of the benefits, and we can work around the manage the risks. Or you say this is actually just gonna end humanity, and then we should not. Closed models built by private companies is not a recipe for safety.
If we really strongly believe, and clearly you and I do, that open source, this is a very deeply important technology for the future of the world. The best way to do it is having really kind of frontier models in the open, very, very transparent. You're starting from all the way from data to model rates. I would estimate today it costs around $500 million to build a frontier model. How do we do this in open? Meta is going to release potentially release a new model, which may be a first frontier open weights model. But how do we sort of ensure, like Linux, that we have a open source project that continues to sort of live and thrive and stay on the frontier?
That's a good question. Do you have any friends who could help us?
If anyone, whoever's watching this, if you have $500 million to add to this effort.
But I think it is interesting thinking about how Linux evolved.
Yeah.
Right. And in the 90s, it was far from clear that it would be dominant or go kind of anywhere. Especially in the early 90s, it was very much a kind of one man show. And I think that first having the independence was helpful. But also having, of course, you need capital and companies like IBM initially in the late 90s, and then Google and others chipping in, I think made it a huge difference. And I think the key thing is about aligning incentives, right? Economic incentives in particular. Right. So no one's just going to donate a ton of money just for something where it's not clear what the benefit is. But I think if we can, as a community, get on the same page with this idea that we want something like Linux for foundation models, where it is independent, it is fully transparent, and it's something that everyone can build on, then I think we maybe have a hope where people can, contribute. And maybe it's one of these situations where, you ask, you take your hat and you go around and you ask each company for 20 million or something.
Right.
And enough participants adding up will result in enough, right?
Yeah.
And this process, it has to be managed, somehow. And I think that in some ways that would be better than having one player control and supply all of it, because then the whole point of this that it remains kind of independent for the community, not it's licensed by one company that eventually decides that, well, you know what, I'm just gonna close it off.
Right. And I would say Linux has created like untold economic value from, if you look at the cloud businesses, which is twice the size of the software business today.
Yeah.
A lot of it became possible because Linux was open and you could really adapt it. SaaS businesses, they are built on, cloud, really powered by open source software in the back end, and you really kind of changes the economics of the products themselves because they don't have to pay a tax.
Yeah.
And you see this closed and open systems sort of happily coexist in fields like operating systems and databases.
Yeah.
So it's something like that. Given we believe that foundation models will also create untold economic value, it seems like that model can be replicated here.
Yeah. There's a lot of details to be figured out, but I think the vision is right, and it makes sense. Right? Why would you have, if right now it's maybe 500 million, in the future it's be of billions dollars. You don't want to have multiple copies of that. Everyone training their own multi-billion dollar model. You should invest in this public good, so that we kind of do it once.
So what else do we need in addition to capital to have a project like this, which is building sort of massive frontier scale models in the open?
Yeah, I think capital is obviously one big thing, which a lot of it would feed compute. I think data is an interesting thing to think about as well. I think at least the open source models are currently at the stage where web crawl, you can do a lot of things, but we know that once you sort of exhaust that, the data, high quality data, is going to be more scarce, and many companies are licensing data and so on. So and there's also copyright issues with data, for example, with books in particular. So I think there's a few legal issues to be kind of worked out there, and beyond that, I think there's maybe a even farther vision of how the whole economy around creators and data and AI should work, right?
Right.
We are seeing a lot of maybe unhappiness with, especially among some artists and writers around, and in general fears about AI taking over some aspect of their the market. And I think this is natural because all of this is coming really quickly, so there's no time to adapt. And also, they weren't involved in the process. So there's a sort of a feeling of disempowerment.
Right.
And I think, again, this is not exactly the open source project that we're talking about, but I think it's adjacent, is to figure out how you can actually incentivize people to help the creation of data that could fuel the next generation, AI. And maybe for this, you can maybe imagine Wikipedia as a kind of a role model here, where again, it's sort of has a feeling of this open, a community where you're producing something that's extremely valuable in the public, and it's all about creating the kind of the data and assets. So I don't have the answer, but I think data is the other big piece that needs to be figured out, and also not just for open models, but even for any foundation models.
Right.
I think this is a big
This
question.
is a big question.
Yeah.
To answer. And related to that, a lot of your recent work has been around evaluations and sort of quantifying the capabilities of these models. Just talk a bit about that. Why are evaluations important?
Yeah, so I've been thinking about evaluations for quite some time now, and I think to start, there's the simple observation that evaluation drives progress in AI.
Right.
If you think about back in NLP, the Pentry Bank from the early 90s drove a lot of work in parsing, and then of course you have ImageNet, which drove a lot of the deep learning revolution, and NLP benchmarks like Squad and Glue and others that drove progress there. And I think one thing that's important about evaluation is that it is an objective measurement, right? It says, here is what I want a system to do, and let's see if your system can do it.
Right.
And I think this is important because it allows research to cross boundaries in the sense that the vision community was very skeptical of deep learning. It's like, no way this is going to work. Right. And it took ImageNet challenge to where vision researchers were trying, and the famous AlexNet came out in 2012 and just like blew the competition out of the water.
Right.
It's completely different paradigm, and vision had no choice but to pay attention to it. Whereas if you didn't have benchmarks, I don't know if that would have.
The burden of proof is on the innovator, rather than being some objective measure.
Yeah, and then you have to argue about, the brain is kind of like working like the brain, and that's not going to go anywhere.
Right.
Whereas you show the objective evidence, it's like, oh, okay.
Yeah.
I believe it. So I think that's why I think evaluation is, so important. And in some ways, that's, especially with API-only models, that's kind of the only thing you can really do. So I think the thing with LLM evaluation or foundation model evaluation in general is that it's very different now. And there's two main differences. One difference is that what's a task?
Yeah.
It's not object recognition, it's not question answering, it's like anything. It's like you type, it's text in, text out.
Right.
And so how do you measure something like that? I don't like to anthropomorphize, but it's kind of like if you're evaluating a human, like how do you evaluate? And we haven't figured that one out over the last 2 millennia or so. So I think it's important and it's challenging. And we have some thoughts that we've been developing, for example, the Helm Holistic Evaluation of Language Models project, where we try to taxonomize different use cases and metrics and try to cover the spaces as well as we can. I mean, it's a start, but I think
it gives you an indication.
Yeah.
Yeah.
And the other thing I think is different is train test overlap or contamination, if you want to be a little bit more edgy about that. So in machine learning, the key way you have to evaluate machine learning, which you learn hopefully in your first intro to machine learning class, is that the training data and the test data has to be independent. Right? You can't evaluate your training set. Everyone knows that. Right? And otherwise you just get meaningless numbers. Now the problem is that this goes back to our discussion about transparency, is that we don't know what's in the training data. So I have these benchmarks, and you get some numbers.
Yeah.
And you see these numbers on Twitter all the time.
Right.
And you don't know what's in the training data, so I don't know. I mean, I don't know how to interpret the numbers. And of course, I think people are generally trying to not sabotage their own models by putting benchmarks, but sometimes accidents happen, or there's often a very I think there's a lot of gray area around what is
You're okay. There's a bug there, but I don't know if I should fix it. It's You're being less disciplined about doing that if you don't have to release your data set.
Yeah, and I think there's another deeper thing is that it's not clear what generalization we want, because people talk about zero-shot evaluation. So I summarize this document. Okay, it's summarized, right? So how impressed should I be about the language model being able to summarize documents? And if it's got a lot of training data of summarize this document, here's that, then I should probably be much less impressed than if it were really kind of truly zero-shot.
I see.
Right.
Yeah.
But we don't know.
We don't know that.
So I think a lot of the qualitative conclusions that we draw from evaluation are really subject to this unknown of whether this training data, did it have not in even individual examples, but did it have the task?
Right. So whether this model is really inherently more intelligent versus has done some rote learning on this particular test to pass this.
I mean, same with humans, right?
Same
like
with humans,
you go, someone aces the SAT, and it's like, okay, well, how impressive is that? Did they study? Did they go through like 1,000 Princeton review books, or did they just like roll out of bed and do it?
Yeah.
And
I guess there's this other really interesting phenomena now, which is of distillation and AI generated content that's now making its way across the data sources that we use to train models, like the web. And there are some statistics that show that eventually more of the web will be AI generated than human generated. How does this work for training and evaluation?
Yeah, it's such a mess.
Good or bad?
It's such a mess out there. Especially with distillation of one model's data into another. And even if you're not doing that, right? Of course, people are using ChatGPT all the time, and then they post their ChatGPT generated content online, and that goes into the web crawl. So, it also muddies a lot of questions around, even copyright.
Right.
And I think that that's sort of just the reality, and I don't think we can really, control that. I think that, to the specific worry that, oh my God, the entire internet's going to be, AI generated. I'm not worried about that use case. I mean, that outcome being necessarily bad, because people are still in the loop, right? There's a lot of selection of what content goes on.
What is
web.
posted.
So if even like half the time ChatGPT doesn't generate good stuff and half the time it does, I take the half that is good, this is sort of some very long-term diffuse version of RLHF, right?
Right.
Where the data that's good gets eventually put online and you train on it. So that I'm not too worried about, provided humans actually are a good judge.
Right.
And this is actually the other piece of evaluation that I'm worried about, is that most humans are not terribly careful when it comes to, not too super critical when it comes to evaluation, right? A lot of these evaluations are LM generation comes out, you have A and B, right? A is a long piece of text, B is a long piece of text. Which one do you like better? I don't know. I mean, A, but I mean, am I fact checking everything? No. And so I think there's sort of a general potential sloppiness where we prefer things that are superficially good, but not necessarily true or fully true. And there could be, subtle, bugs or hallucinations that kind of slip in. And so I think, that's going to be I think we're running into that bottleneck, that the models are so good that, we're hitting the limits of humans being able to really.
So it's sort of the whole thing when as a story is told, it sort of mutates slightly, and it can become a very different story by the time it reaches the nth person. You sort of have models in that chain now.
Yeah.
And the other thing now is we're moving beyond language into multimodality, which is another challenge in terms of sort of evaluations, whether a model is good at multimodal input or multimodal output. How do you think that will impact our approaches to evaluation?
Yeah, so we've been looking at multimodal evaluation a bit. I think it's much less well developed than language model evaluations, but there's some starting to be more in this area. So for image generation, I think that it's just a very ill-defined problem. And one thing that we did in a previous project called HIME is to think about the different aspects of generation that you care about, the aesthetics, the fidelity to language, and think about evaluation as much more multi-metric rather than a single score, like is this good or not.
Right.
And I think the other thing is that I think a lot of evaluation is very impoverished when it comes to the input context. Like, generate me a picture of a sunset. Well, I know, what do you want?
Right.
And what is your aesthetic? And I think that a lot of the, evaluation needs to have more context. Like, otherwise you can't really
It's really a
judge.
more of a subjective thing relative to language, where it's often task oriented and more objective.
Yeah.
Yeah.
But also, with image to text, it's, I think, again, there's a bunch of benchmarks. MMMU is, I think, a solid benchmark that has a lot of different variety of evaluations. But I think some of the same challenges in language model evaluation carry over. For example, train test contamination, which is, I think, perhaps even harder when you have images to deal with. But yeah, I think it's a open problem.
Yeah. Speaking of open problems, I would love to hear your thoughts about AGI and whether it's something that can be measured. Like, AGI is a very evocative concept. I don't even know what it means.
Yeah, me neither.
I guess the answer is we don't know.
I mean, I think of AGI as, it's certainly a term that is useful in a sense that even though no one knows and can define what it is, you kind of like, okay, I know kind of what you're trying to get at. And I feel like, to me, AGI is really about carrying a certain level of ambition and sort of a mindset, as opposed to anything definitional.
Right.
Like, I don't think it makes sense to think about, like, have I reached AGI or not? It's more of a direction, I think, rather than, or a way of doing things rather than in something that you can really nail down.
Right.
I mean, I think when it comes to the benchmarks, I think one aspect of it is that, coming up with more challenging benchmarks that demand more types of reasoning. And we're seeing a lot of that. We're doing a bunch of benchmarks that look at agents in particular. And I think some of these are really hard. So, for example, we had a benchmark called ML Agent Bench, which is you're given essentially a ML engineering task, and you're asking an agent that's based on, let's say, GPT-4 or Claude to solve it. So the task would be, I think one of them is actually make LLM inference faster.
I see.
And right now it's getting basically 0, right?
Right.
But I think it sort of really pushes agents to say, okay, what can you actually do? And for some of the other tasks are like Kaggle competitions where it actually can make considerable progress.
Right. So these are and it's interesting, some of the programming and engineering benchmarks, which were not really designed for models, they were designed for humans.
Yeah.
So they sort of tested the things that were difficult for humans, but maybe not that hard for our current language models. And I guess this is one of the ways in which we can really sort of drive the field forward if we construct these great benchmarks for new tasks.
Yeah. I think one of the challenges is having enough sort of breadth in terms of coverage, because if you think of the G in AGI is really about generality.
Yeah.
Right. And I think the current benchmarks clearly are a very small fraction of all the possible things that a model could do. Right. So how do you really get that coverage without billion hours of human labor?
Right.
One of the things I'm excited about is figuring out how language models themselves can be used for doing evaluation, right? Rather than having individuals construct benchmarks in different domains, how can you automatically generate benchmarks? And of course, this introduces all sorts of problems from, well, if you generate the benchmark and evaluate the same model, how can I trust it? There's some ideas on how you can do it. It's not just like you prompt a language model to generate the model, but you give it some side information, and then the asymmetry allows you to have more legitimate chances at validation. But this is sort of just like...
and this is a way in which you can sort of reduce the amount of human labor required. You still have a human prompting, I want this particular area to be covered with benchmarks, but the hard work of creating the tests can be done by the language model.
Yeah, at least a lot of it, right? The days where someone sits down and writes examples from scratch, I think are over. I think it's just a very inefficient way of building benchmarks.
Right.
And I think humans should be in the loop. They should figure out what's going on. But there's why we should be using these language models to
maximize laziness.
To help us with things, not just efficiency, but actually suggest different options and so on. So I think a vision of this would be you sit down and you write, well, I want to evaluate a language model based on its ability to operate in a contact center. And then you maybe give a few examples of what you're looking for. It generates some examples, and then you can kind of revise or you edit, and then you get a benchmark that you're happy with.
Right.
And I think you want it to get down to you can do this in a few minutes, ideally, rather than spending.
That would be amazing.
Spending a month.
We should build a product around this.
Yeah, sounds like a good idea.
Maybe you can give us a peek into what is coming up in your research that you're very excited about, what the next, I won't say 10, what the next 3 years look like.
Yeah, 10 is a lot.
10 is a lot.
But three is a lot too. I think if you look at my academic research, I feel like it's sort of forked a little bit into things that are really riding on top of the frontier models and pushing capabilities. So for example, all the agent stuff that we develop, all the evaluation stuff, and this has a property that as models get better, the research continues to it's a layer of abstraction above the existing models, right? We had this work last year on generative agents where we're simulating, people in their social interactions, and that's just riding on the fact that we have language models. So that's one direction of research. And then the other direction of research is really going down to the fundamentals of how do we build these language models. And this is why I think I'm so excited about open source models, is that having open source models allows you to look at the internals, to understand the data composition, and understand the differences in architecture that lead to certain types of behavior. So we've been doing a lot of work on data selection, figuring out what types of data can be useful, how to maybe design better optimizers, and I think a lot of that is about building the science of training open source models in a bottom-up fashion.
Right. Percy, this has been an incredibly insightful and useful conversation for our listeners. Thank you for sharing your knowledge and experiences with us.
Yeah, thank you for the great questions, Vipul. It was a pleasure.